Hi guys, we're going to solve this problem in the usual way by first of all identifying which is the chemical reaction that is taking place here. What we can see is that aluminium is set to react with hydrochloric acid, and that produces aluminium chloride because the aluminium has has an oxidation state of +3. That's why we need 3 chloride atoms, and the reaction is going to be similar to the one that we have seen with magnesium or with zinc. That the other product that we obtain is hydrogen. So this is the chemical reaction, the first step. Second step is to balance that chemical reaction, and to balance that chemical reaction, remember, we have to make sure that we have the same number of atoms of the same type on the left and on the right. We are going to begin with the atoms that are not oxygen or hydrogen, so we will begin with aluminium. We have 1 on the left and 1 on the right. We don't have to touch anything there. Then we go to chlorine. We have 1 on the left and 3 on the right. Well, we have to change on the left and right at 3. And after that, we have to make sure that the hydrogen is the same on both sides. 3 on the left and 2 on the right. Well, to make that balance, what we're going to do is to multiply the one on the right by 3, so we have 6, and the one on the right, on the left, we multiply it again by 2, so 3 times 2 makes 6 hydrogen chloride. Now we have 6 atoms of hydrogen on the left and 6 on the right, but we have 6 atoms of chlorine on the left and 3 on the right, so we have to multiply this one by 2. Now we have 6 and 6, and with the aluminium we have to add that final stoichiometric coefficient. Now we have the chemical reaction already balanced. Now we have to work out the number of moles of the information that we are provided with, and we are said to have 216 grams of aluminium and an atomic mass of 27 grams per mole for aluminium. We know the number of moles is equal to the mass divided by the atomic mass, therefore 216 divided by 27 makes 8 mole of aluminium. And this is the number we're going to use for the following calculations. The first question is how many grams of salt are obtained. Our salt is the aluminium chloride. Okay, so the question A, we start from the number that we have, the number of moles of aluminium, 8 mole of aluminium, and then we go to the relation of stoichiometric coefficients. So 2 mole of aluminium produce 2 mole of aluminium chloride. Therefore, this is an easy calculation because we can very easily see that the mole of aluminium disappear, and the 2 and 2 disappear as well. So the result that we obtain is 8 mole of aluminium chloride. But the question is how many grams? For that, we need to know the molecular mass of aluminium chloride. We know aluminium is 27 grams per mole, and we will also have to add 3 times the atomic mass of chlorine, that is 35.5. This makes a total of 133.5 grams per mole. So 8 multiplied by 133.5 makes 1068 grams of aluminium chloride. First number already solved. Second one is how many moles of acid has been spent, and we begin in the same way. We begin with 8 mole of aluminium. This is the information that we have. Okay, ratio of stoichiometric coefficients, so 2 mole of aluminium react with 6 mole of hydrogen chloride. Therefore, what we obtain, we take away what we don't need, is that 8 multiplied by 6 and divided by 2 are going to be 24 mole of hydrogen chloride, and that's the other result. Thank you.